Okay, I'm going to email Sam. All right, ellipses, set of all points whose distance from two foci is summed to a constant. Like, what the heck? No, you don't need to know that for test. And I will give you guys can use your own notes on the test. Can't have examples, but you can write down all the important things that you need. A lot of times people just simply cut these out or rewrite them. It's up to you, but you construct your own notes. Why? Because when I do it for this unit, somebody's always complaining about something. So, like, why am I doing work? All right. If you wonder what that means, and if you don't have it written down, don't worry, we'll come back to it in a second. But the idea is this. If you have a dot, and I pick a value, say 5, and I move 5 units away from there, and I draw all the points that are 5 units away from that dot, what shape do I get? Circle. Not too bad. I'll show you how to draw a perfect circle later on. Okay. Now, suppose that you're going to draw an ellipse. Here's what makes an ellipse different than a circle. Okay. That this ellipse has 2 focal points or foci. And if you pick any spot on that ellipse and you look at the distance that that point is from the 2 focal points, we would have a first distance, d sub 1, and a second distance, d sub 2. If you were to add those together, it would be the same as if you picked another point. I'll put it right here. And you look at that distance, we'll call d sub 3, and this distance we call d sub 4. Those would be the same. Whatever point you pick, they would sum to the same distance. We don't generally know what that distance is, or that sum is, but we don't need to in order to graph it. We just look at the equation. And the equation's in a beautiful form. X minus h, quantity squared, over a squared, plus y minus k, quantity squared, over b squared, equals 1. An equation for an ellipse must be set equal to 1. Now, that is an example of an ellipse that is stretched more horizontally. It has a center of HK, and we say that the vertices are the endpoints of where it is stretched. Anybody want to guess how far the vertice sits from the center? A units. So look at this. All you have to do is look under the x. X is horizontal. It's stretched A units in that direction. So if I move it A units horizontally, is that going to affect the h value or the k value? H. So the vertices will have a location of h plus or minus a, and then a k value. Anybody want to guess how far this one would be stretched vertically? B. So the major axis is the length between the two vertices. How far do you think that distance is? Not a squared, but 2a. Minor axis is how far it's stretched the other way. To b or not to be. The foci, they sit along the major axis. And they sit c units from the center. So again, if I move c units along the major axis, is that going to change the h value or the k value? H. So I have h plus or minus c and k. The eccentricity is a measure of how stretched it is. And you take c and divide it by a. And when you measure the eccentricity, it will always be a number that results between 0 and 1. The closer the eccentricity is to 1, right? If I took this ellipse and I continue to stretch it out, what would it look more and more like? Two parallel lines or eventually one line, right? And if I didn't stretch it out at all, it would just look like a circle. So the closer it is to 0 is a circle. The closer it is to 1, it's a line. Now, there's something you should be asking me right now. How do you find c? Yeah, this c is not in the equation. So the way we find c is this. A squared minus b squared is equal to c squared. It's not the Pythagorean theorem. There's a minus. And those are the basic characteristics of an ellipse that's horizontal. So let's do the vertical one. Now you can see the difference between the horizontal one and the vertical one. Vertical one looks like this. X minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. What's the difference between the two? A and b are flipped. For ellipses, a squared is always the larger of the two values. A is always larger than b, and a squared is always greater than b squared. And that should make sense, because if a squared wasn't bigger than b squared, if b squared was larger, then what would happen when you subtract them? You get a negative, wouldn't you? That'll be a problem. So a squared's always larger. Okay. So we got this center. So HK. How many units do you think this is stretched vertically? A units, because the A sits under the Y. How many units do you think it's stretched horizontally? B. So as we examine these vertices, vertices are the endpoints, again, of the ellipse. As we move A units from the center, is that going to change the H value or the K value? Okay, so we have H, and we have K plus or minus A. What's the length of that major axis? What's the length of the minor axis? And again, C is going to be the distance that the focal points are from the center. So it's C units away. So that will affect the K value. So we have H and then K plus or minus C. And eccentricity is the same. As we graph these, you're going to find them remarkably easier than the parabolas. Again, if you can graph the parabolas, I think you're in really, really good shape. We ready? Eccentricity is like the measure of how stretched it is, and you'll see when we do these next two. But do you know what is so important in real life that involves ellipses? And I'll tell you guys, early on in math history, many, many, many years ago, thousands of years ago, they were studying ellipses. What do you think they were studying that involved ellipses? Planetary motion. Planets travel in a motion that's an ellipse. And so as they start to model, you think of how complicated that was. Okay, no telescopes, no computers, and they're coming up with the equations for planetary motion. Pretty cool, huh? I'd like to take a math class on that, but I never did. Maybe in my future. Oh, here we go. All right. So let's sketch the graph. We'll start with this. Center. Vertices. Major axis. Minor axis. Foci. And eccentricity. Who can tell me the center? Zero, zero. How many units will this ellipse be stretched vertically? 5. Why? Come on, John Zerud, speak up. Just looked right. You pulled the 5 from the 25. It sits underneath the y squared, so 5 units in the y direction. So if I make this a 5 by 5, is that going to be sufficient to be able to graph it? Yeah. So I could kind of figure out my scale for my graph. I'm trying to get you guys to talk a little bit more because you're my most quiet class this semester. You need to speak up if you're ever confused. Have a very non-threatening classroom. Kelsey, if she's in here, she'll make fun of you. Okay. Kelsey understands all mathematics. So anytime somebody doesn't get it, she just belittles them. Right, Kelsey? Got problem 56 all done? All right, you owned it. Way to go. All right, so vertices. I'm going to move 5 units in each direction. So you can either write them as 2 separate points, or you can write 0 plus or minus 5. So that'll be like 0, 5, and 0, negative 5. If you want to write it like that, that's fine. It's up to you. Your choice. America, free country. How many units do I go in the x direction? 2, because of the 4. I'm going to sketch my ellipse, and you guys will make fun of me because it looks so bad. But then you look at yours, and it looks bad as well. Kind of looks like the Eye of Sauron, right? All you Lord of the Rings fans. Yeah, true that. Love that movie. All right. Length of the major axis. What did you say? I'm gonna stay above the line here. Length of the major axis. 10. Very good. Minor axis. 4. Foci and eccentricity. I have to find C. How do I find C? What is a squared? 25 minus b squared. 4 is equal to c squared. So we got 21 is equal to c squared. Root both sides. So c is equal to the root of 21, which is approximately 4.6. Right? So if I move 4.6 units along the major axis, I'm going to get to about these red dots. So the location of those red dots are 0 and plus or minus the root of 21. Eccentricity. What's my C value? Root of 21 divided by A. Yeah, A is 5. Let's actually come up with a decimal and see what we get. Does this look like a parabola that's pretty stretched? I think it does. I don't know. I guess it's all relative. But if I take the root of 21 divided by 5, I get 0.92. So looks like this one is close to 1. So that means it's pretty well stretched out. Okay. And that's it. That's all there is to an ellipse. Not that bad, huh? Compared to a parabola? How do we do on a checkpoint? Okay, all right. But you don't like the parabolas. Oh, you do? Okay, all right. There's one in every crowd. Okay. All right, let's try the next one. How's the next one different? It's not in the form. What do we do to put it in the form? I'd like to say there is something correct about your answer, but there isn't. So what does it have to be equal to? So I divide by, and I get x squared over 9 plus y squared over 4 is equal to 1. Is this going to be stretched more horizontally or vertically? Horizontally. So how many units horizontally? So if I make a 3 by 3, that's going to be enough. What's the center? 0, 0. Good question. You're a potato. Okay. Center, vertices. Length of the major axis, minor axis. Foci. Eccentricity. Okay, so center's at 0, 0. You guys said I go 3 units in the x direction and 2 in the y direction. It's like a potato. So, location of vertices. Yep. Length of the major axis. Minor axis. Foci and eccentricity. What value do I have to find? C. So I take a squared, which is minus b squared, which is c squared. So I get 5 is c squared, or the root of 5 is equal to c. So that means I go the square root of 5, which is approximately 2.2. I go 2.2 units in each direction horizontally. So location of those foci will be plus or minus the root of 5, 0. Eccentricity, square root of 5 over 3. Now, does this parabola look more like, does it look more stretched than the last one or less stretched than the last one? Less. So we would see, hopefully, a value smaller than that 0.9 value. And if I take the square root of 5, and I divide it by 3, I get 0.75. So you can see it's not nearly as stretched as the other one. What do you think? Let's shift them. We'll do 2 more examples. We'll be done for the day. Somebody first hour, they said, I hate graphing. And I said, I hate oppression. You know, it's like, what really, what do you truly hate? You know what I mean? Like, I don't hate the Green Bay Packers. I loathe the Green Bay Packers. You know what I mean? There's a big difference. Hate's a strong word. It is. It brings me joy that Jake likes them. I'm happy that you're happy. All right, center. 3-1. Nice job. No, not 3-1. 3-0. Shifted 3, nothing there. How many units is it stretched horizontally? 3, and then this doesn't have any shift to it. Better? Good question. So how many units does it stretch horizontally? 3. So it looks like I'm going to go 3 units from 3, so it's going to go all the way out to 6. So it looks like if I make a 6 by 6 graph, that should be enough. Am I in your way? Talking to you, Lauren. And Ella. Whatever. Center's at 3, 0. I move then 3 units in each direction. That will give me my vertices. Number one mistake people make on the test. They write their vertices as plus or minus 3, 0. No. Negative 3 would be over here. You don't have a vertice over there. Yeah, 3 plus or minus 3. So you got two ways you can write this. Is 3 plus or minus 3, 0. Or you could write it as 6, 0, and 0, 0. Either way is fine, but you got to consider that shift from the center. Question. Okay. How many units does it stretch vertically? 1. So I go up 1 and I go down 1. And this thing looks like it's pretty stretched out. What's the length of the major axis? 6. Minor? 2. We need the foci and we need the eccentricity. Foci, I got to do a squared minus b squared. What's a squared? Minus b squared. So I got the square root of 8. 2 roots of 2. So c is equal to 2 roots of 2, which is like 2.8. So I'm going to go 2.8 units in each direction. You see the foci are almost all the way out to the edges. That's what happens when you move the foci towards the edges. You get a more stretched ellipse. So again, here's a mistake that people make on the test. For the foci, they write plus or minus 2 roots of 2, 0. Not quite. You have to have that 3 in front. From the center, it shifted 3 plus or minus 2 roots of 2. So I'll write that out so you can see a little bit better. You're going to write 3 plus or minus 2 roots of 2, 0. If you like to write 3 plus 2 roots of 2 and 3 minus 2 roots of 2, that's fine. And then eccentricity. I have to take c, which is 2 roots of 2, and I divide it by a. What's your a value? 3. And when I divide that, I take 2 roots of 2. It looks like it's pretty stretched, so hopefully we should get a value that's close to, 1. And we get 0.94. Wow. Get out of here. Go. All right. So we get 0.94. And you can see that looks like it's pretty stretched. You do the last one on your own. Hint, you have to start by dividing by 36. Once you divide by 36, you should be able to generate the rest. Okay, YouTube Nation, there is your assignment. And now I'm going to shift back just so you can check. You can pause this and look, but this is what you should come up with for your different values. Those focal points, hard to read. I'll write them again over here. -2 plus or minus 4 roots of 2, and the y value is 1. Sorry about my messy handwriting. Trying to prepare them for college. So, okay, go to work.